Welcome back. Once again, this is already the second part of our inferential tests or the inferential statistics, parametric and non-parametric tests. We will going to look into the different tests and how are we going to use it. Most likely in the books, when you're going to read a statistics book, the enumeration of the different gamut of tests are already there, and then the formula, when to use them, and samples will be given. But this time, let's reverse the way you will encounter the different tests. I'll already give you examples of questions or research questions, and then later on, how to analyze it in order to boil down which specific test you need to use. Why is this so? In reality, when you are doing your research, making your thesis or dissertation, you are not really looking at the different tests and then choosing from it and then generating a question out of it. But instead, you are already choosing a topic, writing your objectives, enumerating your statement of the problem, and from that, later on, you'll look into applicable and appropriate statistical tools and tests for each of these questions in order to answer the question. The test will be your instrument. The test will be the manner on how you will process the data that you will gather in order to answer the questions. So if there's a disparity between the question and the test that you're going to use, you do not expect to yield the right answer. So the skill you need to develop here, the competency you need to hone, is the identification of appropriate tests for given scenarios, for given questions or research objectives. So that's the point here. That's the reason why we start with a question, analyze the question, and then select the appropriate statistical test. Because that is how we practice this in reality. So let's start. We start with, again, we have two types of tests, the test of differences and the test of relationship. We start with the former, the test of differences. In the test of differences, again, I'll be showing you different questions, analyzing the questions, and then looking at what specific test are you going to use, given the data that you have are numerical, ordinal, or nominal. So each corresponding we will have a different test to employ. Okay, so let's start. So here's an example of a research question in the inferential question. Is there a significant difference in the pre-test and post-test scores of the experimental group? Now, again, read the question. Is there a significant difference in the pre-test and post-test scores of the experimental group? The first question here is, I'm Siri. Here to help. Okay, going back. The first thing you need to look here is the nature of the question. Is it a test of difference or a test of relationship? From the word itself that appears here, there's already the marker difference, which means you need to classify this under the test of difference. Next, you need to understand that in the analysis of a research question, especially an inferential question, you need to look at three elements here. First, look at the number of groups. The number of set of group of data that are being compared or correlated are important. Are there two groups, three groups, or four or more groups? Okay. Second, how many tests do you see? When you say test here, I'm referring to the variable that is being tested or being used to be grouped later on. So how many tests are you seeing? Okay. Now in this case, there's a pre-test and a post-test word here. So there are two different type of tests, the pre and the post. Or are they this one and the same test? Analyze that. And lastly, the third element will be the number of times the test was given. If you're talking about the pre-test and the post-test as one and the same, essentially the same test, of course, there might be differences in the construction, but essentially and substantially, when you say, I'm measuring you diagnostically speaking on a pre-test for, let's say, reading, and then the post-test will not be on numeracy, but still on reading, which means you're essentially dealing with the same competency and with the same test. But how many times did you give the test? Is it only once, twice, thrice, or more? Encapsulated in this analysis in the understanding that there are independent, dependent, and covariables employed. Okay? So let's look at the analysis here. Again, going back to the question, is there a significant difference in the pre-test and post-test scores of the experimental group? This is a test of difference. That's the first step. Second, how many groups do you see? There's the word experimental group. Does it mean there's also a control group or a counterfactual group? Or when you say experimental group, you take it as it is. You don't imply that there is another group unless explicitly said, which means you only have one group. How many tests? You have a pre-test and post-test. Is it two or is it one? I believe you're only referring to one competency, one test here. And how many times was the test given? Pre and then post. So you have two. Let's see if that's correct. So you have one independent and one dependent variable here. Later on, I'll be talking about it. But in the analysis of group tested times, you see there that you have only one group, the experimental group. You have only one test, the test on that experimental group. And that test was given during the pre or prior to the experiment and then after the experiment. That's why you call it two times. So what if your data, because it scores, your data are numerical. So you will be labeling it under parametric tests. So if your question consists of one group, one test, and two times, under the numerical data, you'll be using parametric test. And what is that parametric test? That will be a t-test. T-tests are usually, or sample t-tests, are usually the comparison of two groups of data. Now, the two groups of data here, it's called paired sample t-test. Why paired? Because when you say you're giving a pre-test, at the back of your mind, or even as a student, you know that the teacher will be providing a post-test. There's no such thing as a post-test without a pre-test. That's why you call it a paired sample t-test. When your tests are dependent to each other, or simply paired to each other, that's why you call it a paired sample t-test. Right? Now, what if your data are not numerical? Instead of pre-test scores, you have pre-test ranking and post-test ranking. That becomes ordinal. Hence, the type of test you will be using is a non-parametric test. And instead of a paired sample t-test, you'll be using Wilcoxon sign rank test. Again, it's Wilcoxon sign rank test. It's a sign rank test because instead of scores, you have the ranking. You have the degree. You have an ordinal set of data being compared. Okay? And then, what if, sir, my data or my scale or level of measurement are not ordinal, but instead nominal data? Then you will still be using non-parametric, but instead of the Wilcoxon, for nominal data, you will need to use the McNemar's test. McNemar's test. So again, let's go on. If you have a question about pre-test and post-test on one group, given two times, okay? One test, one group, two times. And then you have numerical data. you'll be using parametric. You will be using what? Paired sample t-test. If your data or your scale of measurement is ordinal, you will be using non-parametric, and the test that you will be using is Wilcoxon sign rank test. And lastly, if your data are nominal, you will be using non-parametric, and the type of test or the type of measure will be McNemar's test. Okay? See, I'm teaching you the test without the formula yet. Of course, what we need to understand here and to develop is the skill on analyzing the appropriate test for the appropriate research question or objective or situation. Okay? So, let's continue. How about this one? Are there significant differences in the scores of the 4 assessment tests? Let's say for the same assessment test in the same area as the data there of your advisory class. Question, is this a test of difference or a test of relationship? Yes, it's a test of difference because the word differences are already there. Now, here's the next question. Remember the three-prong test? The three-prong question? How many groups, how many tests, how many times? How many groups do you see? You are only referring to the advisory class. When you speak of advisory class, do you have, let's say, 10, 5, or 3 advisory class? In a normal situation, of course, you only have one advisory class. So there's only one group. Next, tests. Second question. Tests. How many tests were given? Type of test. We're talking about the type of test given. It's the same area assessment, the same lesson assessment. So you're only speaking of one test again. And the third question, how many times was the question or the test given? It says here, it was given 4 times. So let's look at the analysis. Again, it's one group, one test, and given 4 times. But this time, I'll make a category that when you have at least 2 groups to compare, that's a basic comparison. You cannot compare if you're only one group unless you're comparing it to a standard. But basically, if you're comparing 2 groups, that's one category. You're comparing 3 groups or more, let's say 4 up to 100 or 1,000, that's another category. In this case, we'll just label it under 3 or more times. So one group, one test, 3 or more times. If your data, as indicated here, assessment, are numerical, let's say interval ratio, your assessment or learning outcomes assessment, the scores of your students, then you'll be using parametric. In the parametric test, if your groups being compared are 3 or more, then you need to use ANOVA. What's an ANOVA? ANOVA stands for analysis of variance. You're looking at the different intervals between the set of scores in a range. Now, that's why you call it analysis of variance. But in this case, there are many types of analysis of variance. And the kind of ANOVA or the kind of analysis of variance you need to use here in this scenario where you have one group, one test, 3 or more times given, you're going to use repeated measures ANOVA. Again, it's repeated measures ANOVA. When you say repeated measures, look at the word measure. It's a test. And you look at the word repeated, the test was given several times, on and on, repeatedly. That's the clue there. That you have only one group, you have only one test, but it was given multiple times. Okay? So that's why you call it repeated measures ANOVA. If your data in the assessment are not interval ratio, but instead ordinal data, then you will be using Friedman's test or Friedman's test. Okay? Again, it's Friedman's test or Friedman. Okay? If your data are nominal, then you'll be using non-parametric and the type of test will be, or measure will be, Cochran's Q test. Have you noticed most of the non-parametric tests are mainly names of the proponents that developed or drafted that formula. Wilcoxon, McNemar's, Cochran's, or even Friedman's test. But when you talk about parametric test, you are looking only at t-test and ANOVA here. T-test when you're comparing only two sets of data. ANOVA when you're already dealing with three or more sets of data. Again, that's the mnemonic for this. So if you have one group, one test, and three or more times tested, then your data is nominal, you'll be using Cochran's test. But if your data is ordinal, you'll be using Friedman's test, this one, or Friedman's test. And when your data are numerical or interval ratio, you'll be using repeated measures, ANOVA. Okay? So let's have a recap. If you have one group, one test, two times given, and your data is numerical or interval ratio, you'll be using paired sample t-test. If you have one group, one test, two times given, and your data is ordinal, you'll be using Wilcoxon sign rank test. Once again, one group, one test, and then two times given. While your data is nominal, you'll be using non-parametric, and the name of the test will be McNemar's test. But if you have one group, one test, but given three or more times, let's say 10 times, and then the data is numerical or interval ratio, you'll be dealing with parametric tests, and that will be repeated measures ANOVA. One group, one test, but given, let's say, 25 times, and the data is ordinal, you'll be using Friedman's test. And lastly, if you're dealing one test, one group, but given, let's say, three times, and your data is nominal, you will be using non-parametric test, and the title of the test will be Cochran's Q-test. Okay? Easy peasy. Let's go to the third question. Here's another question. The question says, is there a significant difference in the science national achievement test scores of the class when grouped according to gender? I hope you have noticed here that the test of difference already had a grouping variable. Again, the question, is it a test of difference or a test of relationship? It's a test of difference. Is there significant difference found there? Which means you're going to only look at the different tests of difference. Now, let's go on to the three markers or the three factors. How many groups? Have you seen here the grouping indicator? The last phrase, with group according to gender. So when you say group according to gender, you're only talking about two, male or female. Unless when group according to gender preferences, you will be implying more than two categories here. The LGBTQ, AA++, undocumented, okay, not just the male and female. Okay, but when group according to gender, again, you are only posed with two options, male and female, which means you have two groups. Next, how many tests? How many tests was given? There's only science NAP, which means there's only one test, Science National Achievement Test. Then, how many times was it given? Unlike the previous question, you have an indicator that it was given several times or two times. But in this case, the science NAT was presumably only given once. There's no indication that it was given again or on several occasions. So which means you have one or you have two groups, the male and female, you have one test, the science NAT, and you also have one time as, let's say, the number of times the test was given. So let's see whether the analysis is right. Two groups, one test, one time. So if you have two groups, one test, one time, the next question is, what kind of data do you hold? If it's a not science test, of course, you're holding scores. Therefore, it's numerical. it's interval ratio. So if it's numerical or interval ratio, you'll be using parametric. And in this case, remember I told you when you're the set of variable or the set of groups you're comparing or set of data comparing are only two, you're dealing with sample t-test or samples t-test. But in this case, it's not the paired sample t-test. The paired sample t-test consists of two groups that are paired. One set of data and one set of time given. But in this case, um, you have, or rather, I correct myself. In the paired sample t-test, you have only one set of data, okay, two times given, but again, one group. In this case, in the independent sample t-test, you have two groups, the male and the female. That's why you have them as two different groups of data, two different sources of data, and yet you're comparing them. That's why it's independent samples t-test. Okay, so it's an independent sample t-test as opposed to the previous sample t-test that we had, which is paired sample t-test, or in other books they call it dependent sample t-test. Okay, now if your data is ordinal and you have again two groups, one test one time, and with ordinal data, you'll be using the Mann-Whitney U test. Again, you will be using the Mann-Whitney U test. Again, if your data is ordinal and the analysis that you had in your question is that it consists of two groups, one test, one time. Now, if your data, same scenario, but your data is nominal, then you will be using the chi-square test. The chi-square test. That's the symbol for that. The x is the chi or chi, and the 2 is square. That's why you call it a chi or a chi-square test. Chi-square test. Again, a recap. If you're comparing two groups, let's say section A from section B, but you have one and the same test given to them, you have given it once only, and then your data is numerical or interval ratio, you'll be using parametric test, and that will be independent sample t-test. But if your data is ordinal, you will be using the Mann-Whitney U test. And if your data is nominal, you will be using the chi-square test. Okay? Next question. Whew. Still, hold on to your seats. The fourth question here entails significant differences in the PHIL IRI stands for the Philippine Informal Reading Inventory Tests. It's a reading test, a reading literacy test for the Filipinos. Okay? And the question here is, are there significant differences in the PHIL IRI results of grade 4 when they are grouped according to sections? Now, the indicator here are sections, which means it's two or more. But let's anchor this on real scenario. In a medium or an average school with grade 4 sections, or let's say an elementary public school, and the grade 4 level here will consist mainly, most likely, with three or more sections. For this case, let's assume we have 5 sections of grade 4. So when you say group according to section, you're grouping them according to the 5 sections. So let's go on with the analysis. Again, what type of test are we dealing here? Is it a test of relation or a test of difference? It's a test of difference. As indicated here in the first phrase, are there significant differences? Now, the next question is the trifocal factor. First, how many groups? How many groups are we dealing here? The last phrase says when grouped according to the section, and we have agreed that there are 5 sections. So you're grouping them according to 5. Next, how many? The second question will be how many tests? Are there several tests here or are there only one? You're only talking about the PHIL IRI. It's a reading test again. So you're only talking about one test. Then the third one, the third question will be how many times was the test given? In this case, how many times was the PHIL IRI given? It is not indicated that it was given again or let's say several times, but instead it's only assumed that it was only given and it's only given once here. So which means you only have one. So recap, you have 5 groups, one test given at one time. So is it the same here? Yes. You have 3 or more groups given at one time, the one test and given at one time. 3 groups or 3 or more groups, one test, one time. If your data is numerical, then again, as I have said, if you have more than 3, let's say 3 or more groups, data sets that are being compared, you'll be using ANOVA or the analysis of variance. But in this case, this is not unlike the previous ANOVA that we had, which is the repeated measures ANOVA. This ANOVA is called one-factor ANOVA, or commonly known also as one-way ANOVA. Why one-way ANOVA? Because you only have one test and given one time, but given across all sections. That's why you call it one-way or one-factor ANOVA. So that factor, that variable was analyzed in all the sections. That's why you call it one-way ANOVA. Again, this is only applicable to numerical interval ratio data under the parametric test. If your data is ordinal, then you will be using the Kruskal-Wallis, still a one-way ANOVA. But again, the nature here, it's customized to ordinal data. That's why you call it Kruskal-Wallis. And if your data is nominal, you'll still be using the chi-square test of comparison. Similar to the previous one, the chi-square test of comparison. So it's a chi-square test. Recap, if you have several groups, 3 or more groups, one test one time, and your data is numerical or interval ratio, you'll be using the one-way ANOVA. If your data is ordinal, you will be using Kruskal-Wallis, one-way ANOVA, or simply Kruskal-Wallis. And if your data is nominal, you're going to use chi-square test. Okay? So, if you have one group, one test 2 times, then your data, let's say your data are numerical, you'll be using what? The paired sample t-test. But if the groups are 2, the test and times are 1, then you're going to use what we have as independent sample t-test. See the difference? If you have one group, one test, but given several times in the parametric scale or parametric test, which means you're using numerical data, you'll be using repeated measures of ANOVA. But if you have several group, one test one time, and your data is interval ratio, you'll be using the one-way ANOVA. Okay, so let's go on. And then, again, another question here will deal with difference. Is there a difference in the optimism scores for male and females who are under 35, 36, 49, and 50 and above years of age? You see here, it's a more complex question, but let's go through with our protocol on how we analyze the question in order to arrive at the appropriate test. The first question will be, what kind of test is this? A test of relation or a test of difference? If it's a test of difference, there's the word difference. Then the next question is the 3-factor question. How many groups? In this case, you'll see here that there's a male and female category. There's the first category group. Then second, there's another group of those who are under 35 years old, those who are under the bracket of 36 to 49 years old, and there's a group of people who are from 50 and above years old. These are 3 groups under the age category. So you have 2 sets of group that has further subdivisions, which means you are dealing with different variables already here. There's a first variable on gender, and another variable on age. See that? Now, what's the next? Group test. How many tests? There's only one test here, optimism score, or the test of optimism. When you say optimism, came from the word optimum, or the best, or when you say optimist, means you're looking forward, or your paradigm or perspective is always of the best, for the best. So that's the test. And then how many times? That's the third question. There's no indicator here that says it was given several times, which means it's only given once. So when you analyze here, you have two independent variables, that is for gender and for age, and the dependent variable on optimism. So there are two or more groups, one test and one time. So if this is the scenario that you have, or the data that you have analyzed from the research question that we have, and your data or level of measurement is under parametric or numerical, then you will be using two-way ANOVA, or the two-factor ANOVA. Why two-way, or why two-factor? You already had two independent groups, but using the same principle as the analysis of variance, that you employ one test given on different times. Okay, so but you have the factor here, or the independent variable that we talk about, are gender and age. Okay, so not given many times, but given on different groups. That's why you have the two-way ANOVA. In the two-way ANOVA, you're looking at three hypotheses here. First will be on the first variable, on male and female, the gender variable. The second variable will be on the age variable. The third variable is this kind of research question or hypothesis also, that you're dealing with the difference given the two independent variable combined. Okay. Now, in this case, when you say two-way or two-factor ANOVA, there are already no counterpart on the non-parametric perspective. There, even though you have ordinal data and then the nominal data. This is the limitation of the non-parametric test. From this point onwards, there are no counterpart or equivalent tests that can commensurate the complexity of the succeeding parametric test. Okay. Another question here is, which intervention, whether the math skills group or the confidence building group, is more effective in reducing participants' fear of statistics, measured across three grading periods? Let's do again the routine. First, is this a test of difference or a test of relationship? If you see there, you're looking at more effective. So you're comparing certain factors, which means this is a test of difference, even though there's no blatant word saying it's a test of difference. So by principle, you're comparing groups. Next, how many groups do you see? Um, if you're going to look at it, apparently or seemingly, there are no several groups, but instead, if you're going to analyze further, you'll see there that there's a math skill category and a confidence building category on the participants. This implies there are two set of group of participants here. Then the next question, group tests. How many tests was given or were given? The test here will be the testing variable, which is the fear of statistics. That is the test that was given among the participants. And then group test, and then lastly, times. How many times was the test given? As indicated in the last phrase, across three grading periods, it was given three times. So you have two groups, the math skills and confidence building. You have one test, the fear of statistics, and you have three times based on the grading period. So let's see the analysis. You have two or more groups, one test, two or more times. Previously, you have only one factor among the three that are several groups, or two or more groups. Then the rest are single or one. For example, two groups, one test, one time, you're dealing with paired sample t-test. But if it's one group, one test, two or more times, you're dealing with independent sample t-test. Am I right? Again, if you have two groups, one test, one time, and your data is numerical, you will be dealing with independent sample. If you have one group, one test, but given twice, then that is the paired sample t-test. Okay? So in this case, you have the groups are several and the times are similar, but the tests are still one. In this case, you have the combination of the first and the second. This is what you call the mixed ANOVA or the mix between within ANOVA. If you see the previous ANOVA that we have or analysis of variance, you have also two kinds. The one is the repeated measures ANOVA. Repeated measures talks about um, one test given one time. Am I right? Um, Repeated measures. The measure is repeated. Okay, one test but several times. Okay, on one group. So you call it repeated measures ANOVA. The second type of ANOVA that we previously discussed talks about several groups, but you have one test and given once to this group. That's why you call it the one way or one factor ANOVA. So when you combine repeated measures ANOVA, which consists of several times, and you also combine the several groups with one way ANOVA or one factor ANOVA, you have what you call the mix between within ANOVA. It has several groups and has several times but one test. That's why you call it mix between within. Between groups and within number of times, you try to analyze the test. Again, that's mix between within analysis of variance. You have several groups, you have one test, and at the same time, several times given. Okay? Likewise, there are no non-parametric counterpart for this ANOVA, this kind of ANOVA, because of its complexity, both in the ordinal or nominal case. Now, what if you have several groups, you have several times, and at the same time you have several tests? That is the moment that your variables are already complex and multitude. Okay? Several groups, several times, several tests. This is the kind of question that implies here, that is implied here. So let's say you have two or more groups, two or more tests, let's say one time or one or more times. This is what you call a multivariate. Again, you call this the multivariate analysis of variance, or we call it the ANOVA. So basically, all of this is the sum total of the parametric and non-parametric tests under the test of difference. In our next lesson, we will be discussing the different tests of relationship.